Hello. In this short video, not so short, today we're gonna look up to transformations. Hey, but whom we are gonna transform? We are gonna transform graphs, functions. Actually, graphs of functions. Yeah, the transform begins. So this is a small topic, you know, and it's an overview. And yeah, you just need to know what are functions and what are functions and what are not functions. Functions and not functions. And what are graphs of functions? Yeah, please request if you want video from scratch, like literally, if you love mathematics. I also love mathematics. You can see here. So if you want video from scratch, you can just tell in the comments. But here in this short 8 to 10 minutes video, I'm gonna give overview. It's actually part one, because I want you to understand intuitively. So I'm gonna give you just a brief overview of something cool, transformation of functions. So what are usually transformation of functions? You know, transformation of functions. Let's not waste time writing here. It's like nothing, but you are transforming function into one and another. And what does that mean? That means like if you are given what is a function, let's talk a little basic. What is a function? And if you guys know what is a function, what is a function? Usually, many people use this word without knowing the meaning of it. Function in mathematics is just a machine that usually describes, just takes an input, x, y, z, alpha, beta, any input, okay? And it gives a specific output, right? Now, this specific output is what being generated by a function. Let's see a simplest function. F of x, which takes input value as x, gives output value as x. Okay? Why does this function even exist? I don't know why, but yeah, it exists. So here in xy plane, we can see that x, if we take x as 1, we would get y as 1. If we take x as 2, we would get y as 2. If we take x as 3, we would get y as 3. So it's just a graph like this. Oh, this is 0, 0. Please mind my drawing. X at minus 1, we will get y also minus 1. X at minus 2, we will get y also minus 2. This is the simplest function that you can see. A linear function, which is a straight line. Now, some of you might have heard what is quadratic function, ax squared plus bx plus c. But we are talking simple here, okay? So what if f of x is x squared? And for your information, x squared is just the number multiplied by itself. So if it is minus a squared, it's just a squared. Okay, so the graph of f of x, which is x squared, looks like this. A parabola. It's 0, 0. At 1, it gives value 1. At minus 1, it also gives value as 1. At 2, it gives value as 4. Like if we input 2 into our f of beautiful x, hey, it's beautiful f of x. Don't get wrong idea. We would get 4. If we input 3, we would get 9. If we input minus 2, we would get minus 2 square, which is just 4. So if we input minus 2, we would get 4. If we input 3, we would get 9. If we input minus 3, we would also get 9. So you got a basic idea what functions are. So what if this graph I can transform with magic, sorcery, to this graph? Oh my god. Oh my god. That's pure magic. Now that is what we call as Harry Potter's magic. Nah, it's not a magic. It's just the graph of x squared shifted up, right? But how can we shift up a graph? That's suspicious. So let us assume that this is x squared. Now, for general, it is f of x plus c. Eh? What? Now, wait. Listen to me, bro. If f of x is x squared, which is general in a quadratic graph like this, then what is a graph of f of x, another function which is x squared plus 5? Let us plot values of x and y. At x is equals to 0, we are getting 5. X is equals to 1, we are getting 6. X is equals to 2, we are getting 2 plus 5, which is 2 square plus 5, which is 9. And x is equals to 3, which is getting 3 square plus 5, which is 9 plus 5, which is 14. So you can see at x equals to minus 1, we are just getting 5. X equals to minus 2, we are just getting minus 2 whole square, which is 4 plus 5, which is 9. Minus 3, we are getting 14. Hmm. At x is equals to 0, what we are getting? 5. X is equals to 1, we are getting 6. X equals to 2, we are getting 9. X equals to minus 1, we are just getting 5. X. Actually, my 6, not 5. 6. Sorry. It's minus 1 square plus 5, which is 6. X equals to minus 2, we are getting 9. Yeah, means I told you like minus a square is just as a square. So the graph is like this. Hey, but the graph we seen earlier, which is f of x is equals to x square, is this. So how it transform into this? I want you to observe here something which is good to observe. That every value of y, like if f of x is x squared, then every value of y, like if you put 0, we get 0. If you put 1, we get 1. If you put 2, we get 4. If you put 3, we get 9. But if f of x is x squared plus 5, if you put 0, we get 5. If you put 1, we get 6. You know, if you get put 2, we get 4 plus 5, which is 9. So, you know, the y value is increasing by 5. You know, 4 plus 5 is 9, 1 plus 5 is 6, 1 plus 5 is 7, 9 plus 5 is 14. So the y value is increasing, means at this point, any point, like if we say which is x squared, at this point, the value of y ups 5 unit. Same for here, same for here, same for every point of the graph. That's why the graph of f of x is equals to x squared plus 5 is just the graph of x squared, which is up in the air 5 unit. Because every value, sorry, 0.5, every value of, of y, a machine, f of x, which was giving x square value, is just adding 5 into the output. So here it add 5 and begin here. At 3, it gives, 14, which is here. So the value are adding to 5. That's why the graph shifted. Same, if f of x is equals to x squared minus 5, it would shift downward. Because at 0, it's minus 5. At 1, it's minus 4. At 2, it's minus 1. And at 3, it's 4. So on. Like the shifting of graph, the shifting of graph on y-axis actually depends on this constant. This constant. Oh, yeah. So what if I say that this is a function, f of x? What would a graph of f of x plus 5 would be? You would say, it would up for 5 unit. You are absolutely correct. This was a previous graph and this is 5 unit. So if it was 0 comma a, it is 0 comma a plus 5. Every point here just upped 5 unit. So from this we can infer 2 point graph of f of x plus a would be just the graph of f of x a unit up the y-axis. Similarly, graph of f of x minus a would be just the graph of f of x a unit down the y-axis. I hope you get it. Now let's talk something really good. Second, f of x is equal to x plus. Hey, what's this? This is something new, right? Let's take a simple function. F of x is x squared. Now we know that value 0 at gives 0. 1 squared is 1, 2 squared is 4, 3 squared is what? 3 squared, what is 3 squared? 9, 4 squared is 16, 5 squared 25, and so on. It goes whatever. But what is f of x plus c? By definition, it is like a function which is taking value x plus c and giving it square. So it's a function which takes value x plus c and give it square with respect to this we are watching. So the graph of f of please. It is graph of f of x, which is x squared. Now, what is the graph of f of x plus 1 would look like? Hmm. You know, magically, Harry Potter's wand did it like this. So it shifted -1. Hey, how, bro? Kuch bhi. So it's x plus 1 square, right? So x plus 1 square is 0 at x minus 1. At x is equals to 0, it's 1. At x is equals to 1, it's 4. At x equals to 2, it's 9. What? It's the same value of f of x square when it is 1, it is 2, it is 3. But now it's not the same. So the graph at 0 gives 1, at 2 gives 9. Usually the graph at 0 gives 0, 1 gives 1, 2 gives 4. But it's not the same thing right now. So you can see the graph is shifted 1 unit before. Especially, like, see, I can't draw. No bad drawing. So at -1, plus 1 square is 0. Hey, I'm coming. Okay, please. Yeah, so let's continue. Someone knocked at my door. Yeah. So I want you to visualize like if f of x plus 1, which f of x gives x square, then f of x plus 1 is just as x plus 1 whole square. The graph would shift towards 1 unit in left. Why? Because x plus 1 square is 0 at -1, right? And at 1, it's at x is equals to 1, it's 4. x2, it's 9. x3, it's 16. It behaves like graph of y is equals to x square. But how can I tell you? It's like 2 plus x at x is equals to 2, it gives square of 3. At x is 3, it's equals to square of 4. It's like -1 through x. So this is the graph of y is equals to x square. You just subtract 1 from every value. So you get this graph. So I know it's a bit messy here. So I just wanted you to intuitively feel why f of x minus 1 graph is just 1 unit left. X plus 1, f of x plus 1 graph. where f of x is x squared. Why it's like this? Because you got it. So what is the graph of f of x minus 1? Similarly, at x minus 1 square is 0 at x equals to 1. At x equals to 2, it behaves like something like 1. It gives value 1 at x equals to 3. It gives value 4 at x equals to 4. It gives value of 9. See, where f of x is x square, it gives value of 1 at 1. When put 2, it gives 4. When put 3, it gives 9. But see, at 1, it gives 0 now. And 2, it gives 1. 3, it gives 4. At 4, it gives 9. So you are giving x 1 more, but the value is still the same. So even though you are giving 1, the value is still 0. Even though you're getting 2, f of x minus 1, f of x is x squared. Even though you were putting 2, the value is still 1. Even though you're putting 3, value is still 4. So you can see the graph goes something like this. It is now shifted 1 unit in right direction. So now we can infer that f of x plus a is just the graph of f of a, but shifted a unit left. Why? Because x plus a would be 0 at negative a, right? Now f of x minus a is just the graph of f of a shifted a units right. Now I want you to answer this question. Let us suppose this is a graph of f of x. Now what is the graph of f of x plus 5 and graph of f of x minus 5? Intuitively, you know that f of x plus 5 will shift left 5 units like this. So exactly this point, not that much, it's not 5 units, but this point, like this, which was let us suppose 20, it's now 15. Yeah. This point, which was now 10, it's on now 5. And f of x minus 5, it would shift more right, like this. It would become 25. It would become 15, the x value. It's just same as those graphs that we were talking about. If f of x is x square, then x minus 5 square would be just like x plus 5 square graph would be just like this because it is 0 at x equals minus 5. Means the whole graph has shifted 5 units before to compensate the loss that it's getting. Similarly, with any graph like f of x is 2x, the graph is like this, right? What if it's 2x minus 1? The graph value, like if f of x is 2x, what is the graph of f of x minus 1? You can see the value of y would decrease by 1 for every x, right? So at x, we were getting this y. At this x, we were getting this y, but now at this x, we would get this y. Sad, you know. So it would be just like this. The graph shifted 1 unit downwards in y direction. But what would be the graph of x minus 1 here? Where f of x is 2x. Let's plot. According to our theory, which we have written earlier, it should shift in right direction, right? Uh, yeah. So let us plot x and y. X, oh sorry, 2x. But for here, x and y. For here, x0, y0, x1, y2, x2, y4, x3, y6. Right? For here, x0, which is 2, x0, it is -2. Oh, okay. x1, it's 0. x2, it's 1. x2, it's 2. Sorry. x3, it's 4. x4, it's 6. You can see that when we were getting the y value of 2 by just putting 1, now we are getting y value of 2 by putting 2. When we were getting the y value of 4 by just putting 2, now we are getting y value of, actually it's written wrong. No, it's right. We are getting y value of 4 by putting 3. 2 into 3 minus 1 is 4. So the graph is just like -2. At 1 it's 0. At 2 it's 2. At 3 it's 4. And at 4 it's 6. It's just like this. Here it's 2. So you can see sorry, at 1 it's 0. So you can see the graph is shifted 1 unit, right? Earlier it was like this. But why? Because we have plotted and we have seen that every value of x means if every value of y at the same x means, just get it, ki if you were putting x is 4, we were getting 8. But now we have to put 5 to get 8. So every value of x has to be increased by 1 unit to get the same value of y. Now got it? Now you can practice some questions based on this. And tada, bye bye. See you in the next video.